everybody, hope you're having a great week. As you can see, I've got my little special guest here, Eleanor, who's going to help out with today's video. And you're really lucky because today I've got a nice good question that I think you might really enjoy. Yeah, isn't that right? So, as you can see by the description down below, today's question is, if I had a number and I halved it a total of 5 times, and after I did all that halving I ended up with a whole number, what could the number I started with be? Okay, so there's going to be quite a few different answers to this, and I want you to really work hard, have a go trying to find as many answers as you can. Yeah, that is absolutely right. Just like Eleanor said, really giving your best. Now, just to help you get started, I'm going to give you a quick example. Okay, now to get started on this problem, I'm going to pick a random number. So I'm just going to think of a number. What number should we do, Ellie Bear? Oh, great idea. Alright, let's pick 20. Let's just say I started with 20. Now, I've got to try and halve this number 5 times. And let's see if we end up with a whole number. So the first time I halve 20, I'm going to get 10. So that's one, I've halved it once. Now I'm going to try and halve it again. Now half of 10 is 5. But here already it looks like we're going to run into some problems. Because now if I try and halve 5, we're not going to have a whole number. And I can show you that by, I can draw 5 circles here. If I tried to evenly halve this, I would end up with 2 and a half, and we can see that half there. So I could write this as 2 and 1/2, or if I'm writing it as a decimal, 2.5. Now, we haven't ended up with a whole number, so we know 20 can't work, can it? It's not going to work. So what you've got to try and find is a number that you can halve 5 times and still have a whole number without having to split into fractions or decimals. Okay, now that I've shared an example with you, it's time for you to go and see how many different answers you can find for this problem. Now I'm going to ask you to pause the video here because I'm going to start to talk about this problem in a little bit more detail in a moment, but I really want you to have a go solving it first before you watch any more. So pause it now, and then when you've got maybe 4 or 5 answers, unpause it and we'll talk a little bit more about what's going on in this problem. Alright, pause now. Okay, welcome back. Now unfortunately our special guest had a very important nap she just couldn't miss, so we'll have to go it alone from now. But hopefully by now you've got around 4 or 5 different answers. If you haven't, that's okay. Just maybe pause the video again and keep searching. But if you do have around 4 or 5 answers, what we really want to do now is start to think about, is there any pattern happening here? Is there anything our numbers have in common? Now something that can really help us understand what's happening here is to understand multiples and how multiples work. So I'm just going to spend a quick minute explaining that now. So, what is a multiple? Basically a multiple is any number that when divided by another gives you an answer where there's no remainder. Now this is hard to think about without giving an actual example. So let's take the number 3. We're going to try and find the first few multiples of 3. Now the first multiple is easy because it's always going to be itself, because 3, if I divide 3 by 3, I'm going to get the answer 1. And so as you can see, it's a whole number. We didn't have to go to decimals or fractions. So the first multiple of 3 is 3. Now the second multiple of 3 is going to be 6, which is basically 2 3s, because 6 by 3 is going to give us 2. So 6 is going to be our second multiple of 3. Now our third one is going to be 3 3s, so it's going to be 9, because 9 divided by 3 gives us 3. And it keeps going on and continues. So if you're thinking about what the next one is going to be 12. Now just to give you another example, let's say this time we've got the number 10. all the multiples of 10 will be any number that 10 can evenly go into when we divide it. So the first one will, like I said, it's going to be itself 10. The second one will be 20 because that's 2 tens. Then 30 will also be a multiple of 10. I know that 100 will be a multiple of 10 because it's got 10 tens in it. Same as 500. 500 will have 50 tens. So these are all multiples of 10. Okay, so you might be thinking now, well, why am I bothering talking about multiples and what does it have to do with this problem where we're trying to halve a number for 5 times in a row? Now that's because every single answer is every single possible multiple of one particular number. So there's one special number in this problem where every single answer is each of its multiples in order from start to finish. So your job now that you've got a few answers is to work out what is that number. All your answers are the multiples of which number. Okay, so once you've had a look at that, pause the video now, have a think about it, and when you think you've got the answer, unpause it and we'll see if you got the right one. Okay, welcome back. Now hopefully you've been able to work out that every single one of your answers is every possible multiple of the number, pause now unless you want a spoiler, of the number 32. So give yourself a big pat on the back if you were able to work out that yes, every single one of my answers are all the multiples of 32. Now really quickly, I'm just going to show you something to explain, well, why is 32 so important to this question where we're halving a number 5 times? Now the way I'm going to show that is with a piece of paper. Okay, so what I'm going to do is I'm going to halve this piece of paper 5 times and we'll see what happens. So I'm going to halve it once. And I've got 2 sections. Now I'm going to halve it again. So this is the second time I've halved it. Now all of a sudden I've got 4 sections. Now I'm going to halve it for my 3rd time. And my 4th time. And lastly, my 5th time. So I've halved this piece of paper 5 times. Now when I open it up, now I've got a whole heap of sections here, and guess how many sections I've got? Well, I've got 4 and 4 is 8, double 8 is 16, double 16 is 32. So by dividing our numbers by 5 times each, halving them 5 times each, we're actually doing exactly the same as if we divided those numbers by 32. And that's why every one of your answers is a multiple of 32. Alright, I hope you enjoyed that one. I hope you got there towards the end. If you didn't, hopefully you can